Good morning, mathematicians. Today we are going to venture into the wonderful world of multiplying fractions. We've worked so hard on adding and subtracting them. Now we're going to think about multiplication. And as we venture into the world of multiplying fractions, you can see our first example here is 1/2 times 6. What is so important to note and to understand the concept of multiplying fractions is a key word. This key word, boys and girls, of is what I think of as the ticket to understanding what is occurring when we multiply fractions. When you see that multiplying symbol between, of course, a fraction here and a whole number, or two fractions or mixed numbers, think about that word of. Of is our key word that we're going to think about as we conceptualize multiplying fractions. I originally said this was 1/2 times 6. Now that we've plugged in this key word, 1/2 of 6, we might be able to think a little bit more clearly about what is happening when we multiply fractions. Let's start with an example with paper clips. So here you can see I have 6 paper clips, 1, 2, 3, 4, 5, 6 paper clips. This is asking me, what is 1/2 of 6? Well, with that keyword and our model right in front of us, we can clearly see that 1/2 of 6 is 3 paper clips. I've broken my set of 6 into 2 sets of 3, and 1/2 of 6 is 3. So in this case, I know my solution is 3. 1/2 of 6 is 3. We see this here with our paperclip example. Let's go ahead and do another one. And this time, let's do 1/2 of 3. Instead of doing this with paper clips, let's take a look at what we've used before with decimals, these decimal squares. I am going to start by asking myself, I want 1/2 of 3. So here is 3. I have 1 whole, 2 wholes, 3 wholes. And I want to know, what is 1/2 of 3? So it's like I'm going to slice my holes in half. Let's pretend like this is perfectly even. And here I would have 1/2 of this hole. Then I would have 1/2 of this hole and 1/2 of this hole. I've taken 3, right? I started with 3. Now I've taken half of 3. Well, when I combine these halves together, this together would give me 1 whole. Then I would have 1 and 1/2. We see here, we start with 3. Now we just take a half of 3. We get 1 whole with these pieces together, and then 1/2. We now have a mixed number. So here, again, boys and girls, we see that the solution is 1 and 1/2. 1/2 of 3 is 1 and 1/2. Let's do one more example so that we can make sense of what is occurring with this idea of multiplying fractions. Here, boys and girls, I want to know what 1/2 of 1/2 is. I wanted to do an example here where we have two proper fractions that are being multiplied together. Let's go back to those base 10 squares that we have used in previous units. Here's a whole, but the question asked me to start with 1/2. I want to know what 1/2 of 1/2 is. Well, here's 1/10, 2/10, 3/10, 4/10, and 5/10. I can see here that I have highlighted half of my whole. So I'm starting with 1/2 of my whole. Okay, now the question is saying, what is 1/2 of 1/2? Well, if I look here, I've started with 1/2. Now I want to take 1/2 of 1/2. That's like splicing that in half again. Here's the half I started with, but I want just 1/2 of that. You can see by looking at the whole, the relationship here in how many parts my whole is now broken into. My whole is broken into 4 parts, right? We started with 1/2 of the whole, but 1/2 of this 1/2 is just this 1/4 of the whole. 1/2 of 1/2 gives us 1/4 or 1/4. Here's my 1/2 that I started with. I just took half of that. That's 1/4 of the whole. Now again, if we go back to how we write that in our number sentence in this abstract way, we see that we have 1/2 times 1/2 gave us 1/4. We see that we have 1/2 times 3 gave us 1.5, and 1/2 of 6 gave us 3. So here, boys and girls, we actually did this with some conceptual models. We looked at paper clips. We looked at base 10 blocks to really see the why behind multiplying fractions. But it's not in every question that we'll pull out base 10 blocks or we'll pull out paper clips. We certainly can do that, but there are some efficient ways that you can go about multiplying fractions. I want us to take a look at those ways now. First of all, to take a look at how we can do this with a procedure, let's think a little bit about this idea of 6 and this idea of 3. These are whole numbers. However, we can express them as a fraction by putting a 1 underneath them. I started with 6, and here I still have 6. 6 wholes, 6 over 1. Here I started with 3, and now I still have 3. 3 wholes, 3 over 1. Do you see how I just made sure that each of these numbers is in proper fraction form or improper fraction form? I don't want mixed numbers or whole numbers in here. As I apply the procedure, I want to see 2 fractions, whether they're proper or improper. Now, watch what can happen when you multiply fractions. When we multiply fractions, we do not need a common denominator. Instead, we can simply multiply our numerators. 1 times 1 equals 1. 2 times 2 equals 4. When I multiply my numerators and multiply my denominators, I arrive at my product. Let's take a look up here at how this one works. I'm going to erase this. We'll remember that our answer was 3. When I multiply my numerators, 1 times 6, I get an answer of 6. When I multiply my denominators, 2 times 1, I get an answer of 2. There's no 3 in there. But we know that when we simplify, we ask ourselves, how many times can 2 go into 6? Well, that goes in 3 times exactly. So our answer here is 3. Notice we did it with paper clips, but with this procedure of multiplying our numerators and multiplying our denominators, we also arrive at that answer of 3. Let's take a look here and see how we get to 1 1/2 by multiplying your numerators and denominators. Here I have 1 times 3 gives me 3. And here I have 2 times 1 gives me 2. Remember to simplify an improper fraction into a mixed number. I ask myself, how many times can 2 go into 3? It goes in 1 time. I have a remainder of 1. This remainder flies to the very top, and my denominator stays the same. I see that I get an answer of 1 1/2. So, boys and girls, we started doing these models with some conceptual ideas, with paper clips, with base 10. And certainly we're going to go back to that idea. However, we're also going to practice this because this is an efficient strategy that can lead us to multiplying fractions. Remember that keyword of. It is like the golden ticket to be able to think about what is happening when we take 1/2 of 6 or 1/2 of 3 or half of 1/2. That keyword of will be a good tool for us to make sense of this new operation in fractions.